Okay, so students, we are here about properties of perpendicular lines, all right? So this unit's called parallel and perpendicular lines. Most of the days, most of the content, most of the things we've been talking about have been about parallel lines. Well, today's the day where we're really going to take a deep dive into perpendicular lines. Perpendicular, incredibly important. Right angles, incredibly important. Lets us know things about right triangles. In my opinion, right triangle is the most important shape us humans have ever discovered, because it helps us just do a whole bunch of things in construction and really just all kinds of technology and architect and engineering type stuff. But anyways, let's dive in. All right, recall that a linear pair are two adjacent angles whose non-adjacent side form a straight or form a line. All right, so I just read that right there. All right, the linear pair postulate says that angles which form a linear pair are supplementary. And remember, I hate the linear pair postulate because I don't think the linear pair postulate should say that the angles are supplementary. I think it should say that they add up to 180, because I think you're kind of eliminating an extra step, but what do I know? I'm just a lowly geometry teacher. They don't ask me these types of things. All right, what happens when the angles in a linear pair are congruent? All right, so this is basically it right here. We have a linear pair. All right, well, they add up to 180. This angle and this angle are the same. Well, find the measure of angle cat and measure of angle pat. Well, the measure of angle cat is 90 degrees. And so is the measure of angle pat. So 90 degrees, powerful because it's the same number that adds up to 180. Okay, so that means that all along right here was a right angle, all right? This is called the congruent linear pair theorem. If two congruent angles form a linear pair, then they form perpendicular lines, all right? So these congruent angles are perpendicular. Sweet. All right, so now let's prove it. All right, a deep dive into proofs. Oh my gosh, a 9-stepper. I quit. I'm gonna go home. Hopefully my iPad dies so I don't have to do this problem. All right, so ATC and STC form a linear pair. We're gonna prove that ATC is congruent to STC. All right. Or excuse me, I misread. And that's a given. We're not proving that. We're proving that they're perpendicular. All right, had a brain fart. ATC, STC, linear pair. That's what LP stands for, and they're congruent. Given. All right. So that angle and that angle are the same. All right. So they are supplementary by the linear pair postulate. Remember, we have buzzwords. We said that they're a linear pair, so we're going to use the linear pair postulate. Okay, another buzzword. Since I said that these two angles are supplementary, I know they add up to 180 degrees by the definition of supplementary. All right. Now, also, so let's just emphasize some things. So linear pair postulate. Supplementary, definition of supplementary. All right. Next is, don't forget we had two aspects of this given. The angles were congruent. So I know that their measures are equal by the definition of congruence. Kind of another buzzword. All right. So, used buzzwords, used what was given to me, and now I can use previous statements as well. So what do I mean by that? Notice how statement 3 and statement 5 are incredibly similar. However, since ATC equals STC, I can replace it. I'm allowed to substitute it in. Substitution. Cool. All right. Now from 5 to 6, notice how I'm just simplifying things. I'm combining like terms. All right, so I'm going to write simplify / combine like terms. You only have to write one of these. I just want you to be aware that you can write either or you might even see CLT. Okay, so now looking at this, I have 2 times the measure of angle ATC. So in number 6, I have 2 times the measure of angle ATC equals 180. Notice how in 7, 2 disappears. 180 became 90. What did I do to both sides? I divided by 2. So it's the division property of equality. But I'm a little bit lazy, so I'm just going to write division. All right. Now, the measure of angle ATC is 90 degrees. So ATC is a right angle by definition of right angle. All right. When an angle is 90 degrees, it's a right angle by definition. All right. And then lastly, what I want to prove, always should get that. And that's definition of perpendicular lines. When there's a right angle, it means the lines are perpendicular. All right, so that's kind of a doozy of a proof. All right, so doozy of a proof. Let's look at this now. Given that CPA and APT are adjacent and complementary angles. So adjacent, remember that means share a side. Complementary means add to 90 degrees. All right, so adjacent and complementary. What do you think is true about CP and PT? So CP, PT, they're 2 adjacent angles. Remember, this all adds up to 90 degrees. So what do we think is true about this? Well, that should be a right angle. So CP and PT should be perpendicular. And that's a notation for perpendicular. It's an upside down T. The notation for perpendicular lines is perpendicular lines. I like that notation. All right. And this is called the adjacent complementary angles theorem. Again, what a well-named theorem. It's very self-explanatory. If 2 adjacent angles are complementary, then their non-adjacent sides are perpendicular. All right, and let's go ahead and prove this. All right, so angle 1 and angle 2 are complementary. Angle 1, angle 2, complementary. Given. And again, we're using buzzwords, so I said they're complementary, so I can say the measure of angle 1 plus the measure of angle 2 equals 90 degrees by definition of complementary. All right. Now, I like this problem because we get to see how we added 2 angles. The 2 angles that add to 90 degrees are complementary. Now we're adding angle 1 and angle 2 to equal a bigger angle. Angle 1, angle 2. We add those together and equals WXS. Right? We're adding 2 smaller angles to equal a bigger one. That's when it's angle addition postulate. Okay? Now, measure of angle WXS equals measure of angle 1 plus a measure of angle 2. 90 degrees equals the measure of angle 1 plus a measure of angle 2. They both equal the same thing, so they equal each other via transitive. Okay, they both equal the same thing, so they equal each other via transitive. All right, so I got measure of angle WXS is 90 degrees. So that means that this angle is a right angle by definition of right angle. So then from there, since we have a right angle, it must mean that the lines are perpendicular by definition of perpendicular. All right, that's it for this video. Stay tuned for more.